Do you know how bizarre the two-slit interference experiment is? A lot of people say it's scary. So what kind of experiment was it, and what was so scary about it? In the late 19th and early 20th centuries, physicists struggled with the question of whether light was a particle or a wave. Previously, Newton believed that since light travels in a straight line and when it meets an obstacle, it will reflect, so light must be a particle. Given his position in physics at the time, Newton's words were biblical. So the particle school, led by Newton, continued throughout the 18th century. But as early as the 17th century, Hooke proposed the theory of light fluctuations. Huygens also refined the wave theory of light on its basis. They agree that light is a wave. The interference phenomenon of light is the most intuitive proof. As a result, the physics community is deeply divided over whether light is a wave or a particle, with each faction convinced that its theory is correct. It was not until the early 19th century that British physicist Thomas Young devised an interference experiment. If light is a particle, then when it passes through two slits, only two stripes will appear corresponding to the slits. And if light is a wave, then after it passes through two slits, it becomes two waves and interferes. It's like two waves on a lake at the same time. The result, as Thomas Young had expected, was streaks like zebra crossings on the screen. His experiment gave the fluctuations a temporary victory and showed the world that authority is not truth. The experiment is easy to understand. But it's the later escalation experiments that are scary. That's the one-particle double-slit interference experiment in quantum mechanics. Because Thomas Young's interference experiments used a serial pattern. The particle school believes that the photon is clearly emitted one by one. How can you adopt the continuous transmission mode for experiments? So the physicists switched the photon gun to a single-shot mode, so that only one photon was emitted at a time. Only one photon passes through the slit at a time. Photons will not be able to interfere with other photons. In theory, there should be two parallel stripes on the screen, but the results surprised everyone. At first, when the number of photons is low, the points of light on the screen look chaotic, but as they add up, there are still zebra crossings on the screen. The formation of the zebra crossing should be the interference superposition between the two wave sources generated by the double slit. But a single photon can't interfere. How does it interfere? Could it be that a photon passes through both gaps at the same time and then interferes? Things are getting more and more complicated. The physicists continued the experiment with these questions in mind, this time adding a high-speed camera in front of the two slits to see exactly which slit the photons passed through and how they interfered. With the help of the camera, photons in single-shot mode pass through only one slit at a time, not in two. But the individual emitted photons seemed to know that the camera was watching it, and no matter how many photons the scientists emitted, only two streaks appeared on the display. When the physicists removed the camera, the photons picked up on the change, and the striped zebra crossing reappeared on the screen. Physicists also discovered the cunning of photons, and conducted delayed double-slit interference experiments, but the results are still the same. Without the camera, light behaves like a wave. A zebra crossing will appear on the screen. With the addition of a camera, light behaves as a particle. Two stripes will appear on the screen. By the time the experiment gets to this point, it doesn't matter whether the light is a wave or a particle, because its properties depend on whether you observe it or not, and this is the real horror of the double-slit interference experiment. Is the world all determined by our subjective consciousness? In order to explain this strange phenomenon, a number of scientists jointly proposed the Copenhagen interpretation, because it involves quantum measurements and quantum superposition in quantum mechanics. Quantum measurement is different from other measurement methods in that once a quantum system is measured, the quantum system being measured will change. This is like the photon in the double-slit interference experiment, which takes on the nature of a wave when not measured. And once it is measured, the photon takes on the properties of a particle. The simple understanding of quantum superposition is that the photon has two different forms of wave and particle due to the two behaviors of being measured and not being measured, which is a quantum system on the superposition of different quantum states. Of course, most people do not agree with this statement, and the most typical one is Einstein. Because he believes that matter is the existence of the objective world. It does not matter whether you measure or not, because God does not play dice. So what do you think of this weird two-slit interference experiment?